Imagine if we could predict an earthquake minutes or even hours in advance. How many lives could be saved? Infrastructure could be evacuated, emergency services could prepare, and disasters could be minimized. The good news is that artificial intelligence is revolutionizing the way we understand and predict earthquakes. Today we're going to explore how advanced algorithms are being trained to detect seismic patterns, which tools are already in development, and how this technology could change the future of global safety. You won't want to miss this. How earthquakes are currently predicted. Before we talk about artificial intelligence, we need to understand how earthquakes are currently predicted. Scientists rely on networks of seismographs, which are sensitive instruments designed to detect and record ground vibrations. These devices measure different types of seismic waves, such as primary P waves and secondary S waves, that travel through the Earth's crust. Currently, most earthquake prediction methods focus on early warning rather than true forecasting. Early warning systems work by detecting the initial, less destructive P waves that travel faster than the more damaging S waves. When an earthquake occurs, sensors near the epicenter send real-time data to processing centers, which then issue alerts to areas further away, sometimes giving people a few seconds to minutes of warning. This brief window can allow automated systems to shut down gas lines, stop trains, and trigger emergency protocols, reducing damage and saving lives. However, these systems are not capable of predicting earthquakes before they start. Long-term forecasting is based on statistical models that analyze historical seismic activity to estimate the likelihood of future earthquakes in a given region. Scientists study fault lines, tectonic plate movements, and stress accumulation in the Earth's crust, but these models can only indicate probabilities over decades rather than precise short-term warnings. Some research also explores precursor signals, such as electromagnetic anomalies, gas emissions, or changes in groundwater levels, but none of these methods have been proven reliable for real-time earthquake prediction. The unpredictability of earthquakes remains one of the biggest challenges in seismology. But what if we could go beyond traditional methods and detect hidden patterns in seismic data that humans can't perceive? This is where artificial intelligence comes in, offering a new way to process vast amounts of geological data and potentially predict earthquakes before they even happen. How AI is revolutionizing earthquake detection. Artificial intelligence has a unique ability to analyze massive amounts of data and identify patterns that humans would never notice. Traditional methods of earthquake detection rely on predefined rules and thresholds, but AI can go beyond these limitations by continuously learning from new data and adapting its predictions based on complex, non-linear relationships in seismic activity. Machine learning algorithms are being trained on historical seismic data to detect subtle signals that may indicate an impending earthquake. These signals can include microtremors, changes in underground pressure, and even anomalies in electromagnetic fields. Some deep learning models use convolutional neural networks, CNNs, and recurrent neural networks, RNNs, to analyze waveform patterns from seismic recordings, distinguishing between normal tectonic movements and potential precursors to larger quakes. Other approaches involve unsupervised learning, where AI clusters seismic events into patterns that human experts may not have previously recognized. Researchers have discovered that certain patterns of seismic activity and even slight changes in the Earth's crust can serve as warning signs. AI models can process massive datasets from multiple sources, including GPS sensors, satellite imagery, and underground pressure readings, to identify anomalies that might signal an upcoming earthquake. Additionally, AI can integrate data from IoT, Internet of Things devices, such as smart seismic sensors placed in urban areas, to refine predictions with real-time monitoring. One of the biggest advantages of AI in earthquake detection is speed. With traditional methods, analyzing seismic activity manually can take hours or even days. AI-powered systems can analyze these signals in real time, providing faster and more accurate predictions. Some experimental models have even shown potential for detecting foreshocks, small tremors that sometimes precede major earthquakes, allowing for the possibility of short-term warnings. While this technology is still developing, its ability to recognize patterns invisible to humans offers a promising future for earthquake forecasting and disaster prevention. Tools being used or developed. Several tools and projects around the world are already using artificial intelligence to predict earthquakes. combining machine learning with real-time data collection to improve detection accuracy. These systems utilize a variety of data sources, including seismic networks, satellite monitoring, and even crowdsourced smartphone sensors to refine predictions and provide early warnings. Google, for example, is working on an alert system that leverages the accelerometers in Android smartphones to detect seismic waves. Since P waves travel faster than the more destructive S waves, the system can issue alerts seconds before the shaking reaches populated areas, giving people crucial time to take cover. This approach transforms millions of smartphones into a global, low-cost earthquake detection network. Additionally, companies like Palert Taiwan and Shake Alert in the US are integrating AI into their early warning systems. Shake Alert, developed by the U.S. Geological Survey, USGS, in collaboration with universities and government agencies, uses a network of seismic stations across the West Coast to detect initial tremors and trigger automated alerts. AI is helping these systems improve their filtering mechanisms, reducing false alarms by distinguishing between real seismic activity and background noise caused by human activity or weather events. At the forefront of academic research, a Stanford University project is using deep learning models to analyze micro tremors and detect foreshocks that could indicate an impending earthquake. By training neural networks on vast data sets of past earthquakes, researchers have found that AI can recognize hidden patterns in seismic activity, providing a new way to anticipate tremors before they strike. Similarly, MIT scientists are working on AI-powered predictive models that analyze underground pressure changes and fault line stress accumulation to identify high-risk zones with greater precision. Another promising initiative comes from NASA's Jet Propulsion Laboratory, JPL, where researchers are developing AI-driven systems that analyze satellite imagery and GPS data to detect minute shifts in the Earth's crust. These subtle deformations, often invisible to the naked eye, could serve as early indicators of seismic activity. By combining AI with remote sensing technology, NASA aims to enhance earthquake forecasting on a global scale. With advancements in cloud computing and edge AI, some of these tools are becoming even more efficient, processing seismic data closer to the source rather than relying on centralized data centers. As these AI-powered systems continue to evolve, they are not only improving early warning capabilities, but also reshaping how we understand and predict earthquakes, potentially saving countless lives in the process. The impact of this technology in the future. If AI-powered systems continue to evolve, we could reach a point where earthquakes are no longer completely unpredictable events. With more accurate forecasting, cities could implement proactive evacuation plans, reducing casualties and economic losses. Emergency responders would have more time to prepare, ensuring faster medical assistance and coordinated disaster relief efforts. AI-driven predictive models could allow governments to enforce stricter building codes in high-risk areas, designing structures that can better withstand seismic shocks. Critical infrastructure, such as power plants, bridges, and water supply systems, could be automatically protected using AI-integrated safety protocols. For example, AI systems could detect early seismic signals and instantly shut down gas lines, preventing explosions, or halt train operations to avoid derailments. High-risk industrial sites, such as chemical plants and nuclear facilities, could implement real-time AI monitoring to minimize the risk of catastrophic failures during earthquakes. Looking further into the future, AI could help refine long-term earthquake forecasting. By analyzing decades of seismic data, stress accumulation in tectonic plates, and even interactions between atmospheric and underground conditions, AI models may provide accurate probability maps for future seismic activity. This would enable governments and urban planners to develop smarter, more resilient cities, with infrastructure designed to withstand potential quakes before they occur. The combination of AI with other emerging technologies, such as quantum computing and advanced sensors, could further enhance predictive accuracy. Quantum algorithms may process vast datasets at unprecedented speeds, uncovering hidden seismic patterns that are currently undetectable. Meanwhile, AI-powered satellites and IoT-connected seismic sensors could provide continuous global monitoring, making earthquake prediction a near-instantaneous process. Although AI is not yet capable of providing precise long-term earthquake predictions, its ability to process and interpret vast amounts of data in real time is already transforming the field of seismology. With continued advancements, we may be approaching a future where earthquakes no longer catch us off guard, turning what was once an unpredictable force of nature into a manageable risk that can be mitigated through technology and preparedness. Conclusion: Artificial intelligence is already transforming the way we predict earthquakes, and the future of this technology promises to save millions of lives. But will we ever be able to predict earthquakes with 100% accuracy? What do you think? Leave your comment below, and don't forget to like and subscribe to the channel for more content on technology and innovation. See you in the next video.